I spent $30,000 making a clock, and I'm gonna show you the engineering behind this thing, how I spent this money, the mistakes I made along the way, and why I'm open sourcing the entire thing. You see, because this is not just a clock, it's an air quality monitor disguised as a clock. A couple years ago, I started working from home. 3 p.m. would hit and I would get a headache. I would feel fatigued and I had no idea why. I thought maybe it's the coffee, maybe it's the lack of sleep. Well, long story short, it turned out to be my air. How do I know? One day, when I was feeling exhausted, I decided to open up a window. And sure enough, soon after I started feeling better. But there's an issue. I wanted to know I needed to open a window before I started feeling crummy. So I started to do deep research. I wanted to get an air quality monitor that I could keep around on my desk. But none of them check my boxes. I wanted something that was open sourced so I could actually own the hardware. I didn't want any more apps and any notifications on my phone. And I wanted something that's battery powered. So that way I could stick it on a wall, put it on a desk, put it somewhere on a bookshelf. But I didn't want it to be just an air quality monitor. I like to keep my desk to a minimum. So putting a clunky air quality monitor there just felt strange. And me being me, at this point I knew I had to engineer something instead of buying it. So I sat down and started writing requirements. Here's what I came up with. Number one, which is probably the most important requirement out of all of them. I wanted to put these all over the house, so it had to pass the wife test. I wanted it to be portable, so it had to be battery powered. The display had to be readable at all times. And most importantly, I wanted it to be more useful than just an air quality monitor. It had to be completely offline, no apps whatsoever. And of course, it had to measure air quality index, temperature, humidity, all the standard stuff. And most importantly, it had to be open sourced. Easy enough, right? Well, requirement number one actually turned out to be one, the most expensive, and two, probably the hardest out of all of them. The device had to look good, and not DIY good, but product-like good. And this is where the actual story begins. For parts, I knew I wanted to go with an e-ink display. These look great, and they don't use any power unless they're being refreshed. As a matter of fact, this one is not even connected to anything and it's still displaying the message. This made it the perfect candidate for the project. What's the catch? Well, these are fairly expensive, but they do look premium. With the display out of the way, it was time to tackle the most important thing. This needs to be a good air quality monitor. And this is where I ran into trouble. I spent months researching and studying every aspect of indoor air quality. Modern homes are sealed so tight that the VOC buildup inside can be 2 to 5 times worse than outdoor air. You cannot get a VOC measurement inside of your home unless you have a dedicated device. But there is a problem. VOC sensors consume a lot of power. The way VOC sensors work is by heating up a resistor plate that's inside of the chip and then measuring the resistance across the plate as VOC particles hit that plate. But in order to heat up this plate, well, you've got to use a lot of energy. Luckily, the best VOC sensor on the market, the ENS161, has a low power mode. The only downside? Well, it only refreshes its data once per minute. But lucky for us, our clock refreshes the time once per minute as well. And speaking of the clock, it actually is not as simple as it sounds. I built the entire thing based on the ESP32H2. That way it is easy to hack and tinker with. I could have put down an ARM controller instead of the ESP32, and I probably have saved myself quite a lot of headaches. ESP32s are power hungry. A Cortex M0 Plus? Well, they draw almost no power whatsoever. And I used to literally for the last 10 years develop on the ARM architecture. But it would be hard for majority of the people to hack and tinker with this if it was based on the ARM controller. I want you to be able to dig through the firmware, modify things, make your own custom UIs, and have fun. Also, ESP32s have a ton of peripherals. I needed a real-time clock, but there's an issue. The real-time clock inside of the ESP32 drifts up to 10 hours per month. 10 hours per month! That's 8 minutes a day. It is extremely inaccurate. These chips expect to be time corrected by an app or from the internet. And the device I'm making here is going to be completely offline. So this was not usable. In order to solve that, I had to add a real-time clock onto the board. But now the time drifts up to a minute per year. It is extremely accurate. But of course, me being me, I had to learn this the hard way. There were 7 revisions of this PCB. Well, I'm not gonna get into all of the details here. It would be an hour-long video. It took a lot of effort to get to this point. I spent about $2,000 on PCBs alone, which makes me want to jump into the worst spent out of all of them. The enclosure. As mentioned before, I knew this thing needs to pass the wife test. It couldn't look DIY. Now, I 3D print some of my products, but at the time when I was making the clock, I did not have access to these high-end machines. So I went with the next best thing. I decided to CNC the enclosures out of aluminum. And when you CNC a single part, it costs an arm and a leg. And I didn't want just one copy, so I made 100. I spent over $2,000 on CNC'd enclosures. And the problem? I didn't like any of them. The finish was odd, I just didn't know what I was doing. So to double down on the pain, I decided to make CNC'd stands as well. What could go wrong, right? These turned out to be unusable as well. They look good. The finish was right this time. But the first time I lifted the clock with the stand attached, the stand fell and nearly hit my toe. It was super heavy. That's another $2,000 just gone. At this point, I was $6,000 in and, I couldn't go back at this point, right? Cut my losses, go back, maybe? Nope, no, not at all. I doubled down and went all in. Now, I am not a mechanical engineer by any stretch. I've done a few small projects that were injection molded, but I'm nowhere near an expert in injection molding. So I took a gamble. I redesigned the case to be suited for injection molding. I added draft angles. I made sure the plastic was as even as possible. I spent weeks perfecting the thing. Finally, I was ready. For sure, I could get it right the first time, right? Well, we all learn from our mistakes. And this mistake was so simple and so stupid. Oh man, it actually hurts to this day. I didn't specify the position of the injection of the gate. This is where the plastic enters the cavity. The enclosure itself otherwise came out great. Actually, really good, surprisingly. Except for this. It has a dimple and it looks so weird and ugly. And at this point, I've made a decision in my mind. This is no longer a weekend project. This is going to be a product. I want to build this and actually deliver it to the world. So I just couldn't accept this. $5,000 gone. The mold itself for injection molding is extremely expensive to make. In essence, it's a negative of your design. This is a small hobby scale one. Industrial designs are usually a huge chunk of metal. But the advantage of a mold is that you can reproduce your part super quickly and in large quantities. And usually pretty cheap, except I decided to make my parts in the US. It's $4 per piece, not for the whole entire clock, but per piece for each individual part. Anyway, I changed the position of the gate. I made something called a hot gate in the middle That way, the whole entire thing is absolutely perfect. I added magnets inside of the back, that way it could snap onto a stand. The reason I made a stand is so I can also reposition it between a stand and a wall mount. The whole entire clock looks like it's floating. It's absolutely awesome. But to produce each of these pieces, $5,000 each. The mold, again, is so expensive. But to add to the pain, because I redesigned this part twice, that was an additional $5,000. And we're not even close to being done. And spoiler alert, it actually was more than $30,000. Right, and back to the wall mount for just a second. If you're gonna learn anything from this video, prototype your stuff. Just prototype, and prototype as much as you can. Because once you commit to a design and you put money in, that's money you could have spent on marketing and anything else, just an FYI. The wall mount was a huge mistake. I thought it would look good. I wish I prototyped it better, but it is what it is. Another $5,000 gone. Now, since I have declared for this to be an actual product I am going to sell, there were a few small things left to do. But before I tell you, let me show you what the clock in the end looks like, because my opinion, I know I'm probably biased, it looks amazing. At its core, it's a desk clock. It uses an e-ink display, so the key information is always displayed. There are no lights, no notifications, no distractions of any kind. But when it wakes up, it checks the air quality around you, and then it updates the screen very gently in the background. The way I use it is very simple. Most of the time it's just a quiet clock. But if I start feeling tired or the room just feels weird, I can glance over and check to see if my air quality has changed. And here's a cool feature I've put in that I actually look forward to every single morning. Once a day, it gives me a quote that keeps me driven, it keeps me going. This is what I really wanted. A device that helps you become less distracted, keeps an eye on your air quality, it's useful, and it's not another distraction. Now, I added the clock as a justification for this to have a spot on my desk. But honestly, it quickly became my favorite feature out of the whole thing, followed by the quotes, which I look forward to reading every single morning, even though I handpicked them. Also, I went with the rechargeable batteries. The last thing I wanted was to make this device with some weird odd-shaped batteries that you gotta replace once in a while. Instead, you could just plug this thing in, charge it up, and off it goes for at least 2 months. Speaking of, I ripped out some hair, and probably, maybe you can't tell, but I ripped out some hair trying for this thing to be as power efficient as possible. I spent months trying to optimize this thing. And of course, probably the most important thing is that it's fully open sourced. All of the designs and all the files are up on GitHub. It's been a long time in the making, and it's finally time to release this thing into the wild. The first batch is capped at 200. I'm calling it the Founder Edition. I'll have a link in the description below. So where did the last few $1,000s go? Well, in order for me to legally sell these, I had to go through FCC testing and I had to make a box. FCC testing cost me $2,000. And the boxes? Well, I went with a premium option. So those ran me quite a bit as well. But the boxes, they're great. They open up like an Apple product. It looks awesome. But there's a problem. There is something a little odd about these boxes. They do not say stock app prototype. There's an entire story behind this, and for those first 200 units, I'm going to hand sign and number every single one, and I'm going to include a letter explaining what happened here. And it's an entire story. So do I regret spending over $30,000 to make a clock? Well, it's more than a clock. One, it's a story, and now it's an actual product. And even if it doesn't work out, and let's say I never sell a single unit, I'm open sourcing the entire thing. I hope it teaches you something and that you learn from it. Or at least from my mistakes here in this video. Thanks for watching, and I will see you in the next one. Bye.